Hello, so this is my Excel project using Solver. So basically, what it is we have a profit that we want to optimize, and using these quantities, we can optimize it by placing it like first placing our goal, which would be maximizing this profit right here. So we can select it, or then yes. For the variables, it'll be profit per item. And this, we don't want to be negative. So we can select them by adding to the solver here. An important thing to know about solver is that it doesn't come with Excel. So I had to import it, but I have a Mac. So I think that's why my version of solver came out different. Let's see what we have here. 5. This is the range we want. Go. We added it though. Adding it again. We go. Now for the constraints, this these are the values you want the rules to follow. So for the items, we want at least 200 to be item A to be produced, and the solver will follow these rules basically. And for item B, we want 20, at least 20 to be produced. For product C, we want at least 50 to be produced, and for the total, we want a total of 350 to be produced. So what we're trying to do is by following these rules for quantity, we want to figure out which quantity and at which price will maximize overall profit. So here we can add constraints. So this first one you want is greater to be equal than 100, because you want at least 100 to be produced. Add 50. We want at least 20. It should be 20. Here. We want at least 50 to be produced. This last value we want. So these would be the constraint rules you want to follow for like the quantity you want produced. This is the model. This. Then for the engines, we have 3 we could use to solve the problem. I believe LP or simplex should be the one used, because evolutionary and nonlinear, or when like data is not like following a set pattern, or like, hard to explain, but LP simplex should be the one used. I'll just try this. And then let's try to run this optimization and see what we get. It seems to be working. So let me try inserting an example. Okay. Okay. So here, like they said, the maximization at D18. So yes, this is the total price they want to optimize for, which way they have maximized the value here. The variables will be D9 to F9. D9 to F9. Okay, so this looks like the quantity. And then where's the constraints? So, okay. Here they have their constraints greater than or equal to 0, less than or equal. Okay, so they're using two rows here, and they want less than or equal for each of these values. They're not using a model, which is maybe why mine didn't work earlier. And they're using standard LSG and linear. So let's try running this. Okay, so now we're seeing these values change. So if we optimize for, let's say, instead of D18, if you wanted 2,500 instead, let's see, D17. Let's try turning these values up. And actually, let's just try minimizing this, see what we get. Okay. So this is giving us a minimum value. So we can, the solver allows us to like basically maximize for value, minimize for value, or we can set a specific value we want. Let's say like 9,000. Let me run this. And it will follow all the rules that we basically put into it. It's cool. And this can be used basically for as long as like multiple different business types, which is why I think it's very interesting. Let's try 500 here. Maximize. 500 here. Trying to play the values a little bit. So yeah, with solver, by giving it constraints using greater equal to, we're able to like play with the values or the rules we want, and then we can maximize for a profit quantity we want. And using these data types, we can go over like the linear to find basically which price matches our criteria. So that will be solver.